We're supposed to approximate this integral using 5 partitions, and you want to find the lower and upper Riemann sums. So in class we graphed this and we saw that it looks kind of like this, basically. So we know that from 0 to 1, it's steadily increasing. So that means that an upper bound is going to be a right-hand sum. Because the right side is always going to be greater than the left side. So we'd start off by taking the interval from 0 to 1, which is 1, divided by 5. So that means each one of the partitions, I didn't draw this big enough, but 1, 2, 3, 4, 5, yeah, there's 5 of them. So each one of the partitions is 1/5 long. And then on the inside, we're going to have the square root of 1 plus, and since we're doing right-hand sums, that'd be 1/5. Oops, I just can't get this. 1/5 squared. So that'd be the first height. Second height would be 1 plus 2/5 squared. The third height would be 1 plus 3/5 squared. Fourth heights would be 1 plus 4/5 squared. And the fifth height would be the square root of 1 plus 1 squared. And if we add all those things up, we would get the upper bound. The lower bound, in this case, is going to be a left-hand sum. So that would be, again, 1/5. The partition size doesn't change at all. And this is going to be just like the top, except for I'm going to start with the square root of 1 plus 0 squared. And it's going to be the same, but it'll end with the square root of 1 plus 4/5 squared. And all these things in the middle will be the same. So it's basically these 4 right there, and then that one extra one. So that would be my upper and lower bounds. Okay, and so again, the connection here is the connection between Riemann sums and integrals. So if we scroll down here, this one, if you don't remember what arctan looks like, it looks basically like this, where this is pi over 2, and there's an asymptote there at negative pi over 2. And since pi over 2 is like 1.6-ish, then that means that 1 and -1 would cut it off somewhere. 1 and -1 are, yeah, so 1 and -1 would be right in here somewhere. 1 and -1. So if we want to approximate that, now remember we talked about this in class, that when area is below the x-axis, we think of it as negative area. And when area is above the x-axis, we think of it as positive area. So this is actually going to, if you look at that thing, since this is the same as that, this is actually just going to be 0. Isn't that interesting? Okay, let's hop down to this one down here. So we're going to approximate this once again, and we're going to have, and 3 to the x looks something like that. So if I'm going from -1 to 0, that'd be from there to there-ish. That's going up all the time, so the right-hand sum is going to be upper again. So upper is going to be, once again, the distance is 1, so that'd be 1/5 times 3 to the 1/5, or 0.2, plus 3 to the 0.4, plus 3 to the 0.6, plus 3. Whoops, my bad. Those are supposed to be negatives. I messed that up. Okay, let's back up a second. Sorry. So the first one is going to be 2/5 to the right of -1. So that'd be 3 to the negative 0.8. Because 1/5 is 0.2. Plus 3 to the negative 0.6, plus 3 to the negative 0.4, plus 3 to the negative 0.2, and plus 3 to the 0. That'd be my upper. My lower bound would likewise be 1/5 times, same idea, except for we're going to start one earlier, so that'd be 3 to the -1, plus 3 to the 0.8 negative, plus 3 to the 0.6 negative, plus 3 to the 0.4 negative, plus 3 to the negative 0.2, and that would be my lower bound. And we got one more here, log base 2. So this one is going from 1 to 4, so that's a 3. So the interval is going to be 3 divided by 5, because we're still doing 5 partitions. Log, if you don't remember what log looks like, the basic idea of a logarithm is it looks something like this, right, roughly. The main reason we do that is we can figure out where it's above and below the x-axis for negative, positive area, but also so we can tell if it's steadily increasing or not. And it is. And this happens to occur right at 1. So we're really just going from here to say, so 4. If we were to draw a quick sketch, it would look something like this, let's say. So we're trying to find this area in here. I should put some little intervals in there. So that'd be like 1, 2, 3, 4. So there's my 5 intervals, right? So if we're doing right-hand sum, it would look like this. Right, that'd be a right-hand sum, and that would be an upper once again. So that would be 3/5 times log base 2 of, we're doing the right-hand sum, so that would be 1. Now 3/5 is the same thing as 0.6, right? So that would be 1.6 is where I start. That's that guy right there, right? Plus log base 2 of, and I'm going up by 3/5, so that'd be another 0.6. That'd be 2.2 plus log base 2. Go up another 0.6. That'd be 2.8. Go up another 0.6. That would be log base 2 of what? 3.4. I mean, if I got 1, 2, 3, 4, so I need one more, plus log base 2 of 4. So that would be my upper. My lower would be 3/5 times, and all those same things, except for drop off the log base 2 of 4 and add in a log base 2 of 1. That'd be my beginning one. And this would go there, this would go there, this would go there, this would go there, and I'd be done. Okay. I think we talked about these in class, so I think I'll end this video.